Here we demonstrate a typical hypothesis testing phase for analyzing syndromic hotspots. First, the user selects the syndrome of interest, in this case respiratory syndromes. Typically, the patient distribution is shown as a percentage of the number of patients with a given syndrome over the total patients seen aggregated over some spatial area, usually by county or zip code, as shown here. Another method of aggregation provided by our system is to group patients into circular clusters based on their distance from each other. The size of the circular clusters represents the total number of patients, and the color represents the percentage of patients showing signs of a given syndrome within that cluster. Unfortunately, both methods of data aggregation lack key pieces of contextual information that may mislead users. Notice that when the data is aggregated by county, several counties immediately stand out to the user, indicating that these areas warrant investigation. However, if we simultaneously plot the aggregate data, we see that those areas contain such a sparse number of cases that their aggregate data is not shown. Furthermore, if we adjust the color scale to bin the data based on linear, exponential, or logarithmic distributions of their data, we begin to obtain a better contextual understanding of the data spread. Our system also employs the use of a variable kernel density estimation to model the population distribution across the state. Here the video is time-lapsed as our current implementation is still unoptimized. Again, users may map the aggregate data on top of the kernel density heat map to gain a better contextual understanding of the data. Note that in key areas we see either contradicting information, cool spots with hot data aggregation, or collaborating information, hot spots with hot data aggregation, that need to be investigated. Users may select these spots with a circular selection tool to bring up the temporal information of that region, providing further context. Note that in the current version, the circular selection tool is not interactive as queries to the database are still being optimized. The video has been time-lapsed. In order to further contextualize the hotspots, users may zoom into the map. These zooms result in an updated kernel density estimate as the patient locations are now mapped to the new enlarged grid. The resultant density estimate calculations are currently not interactive. As such, the video is again time-lapsed ahead. When investigating these hotspots, users may interactively adjust the color map to enhance contextual information. Here, we see that the majority of the map is binned to one color. As such, areas with large peaks may be hidden. By interactively adjusting the color scale to a finer granularity in that region, we can observe previously unseen peaks within the hotspot.